Hey guys, welcome back to another episode of How to Hack Ethical series. Hope you are all doing good. Today I am going to talk about the difference between hashing, encryption, encoding and obfuscation. Well, if you think that hashing, encryption, encoding and obfuscation are the same thing, you are wrong. However, you're not alone. There is an awful lot of confusion surrounding these three terms. As similar as they may sound, they are all totally different things. Before getting down to business though, let's understand a few things first. From a security point of view, what are the most important things when sending data/message on the internet? First, you want to let the other person know that the message has been sent from you and not from anyone else. Second, you want the message to be in the exact same format, without any alteration or modification. And third, you want your message to be protected from the reach of hackers, fraudsters and other types of cyber criminals. These three functions can be designated as identity verification, integrity, and confidentiality. So, how exactly is this done? Hashing and encryption are the answers. Now you must be thinking, doesn't that make them the same thing? The answer is no. What is hashing? Let's try to imagine life without hashing. Suppose it's someone's birthday and you decide to send a happy birthday message. Your geeky and funny friend decides to have a bit of fun at your expense, so he intercepts it and turns your happy birthday message into a rest in peace message. Imagine the consequences. This could happen and you wouldn't even know it until you are at the receiving end of certain reactions. Jokes aside, hashing protects the integrity of your data. It protects your data against potential alteration so that your data isn't changed one bit. Basically, a hash is a number that is generated from the text through a hash algorithm. This number is smaller than the original text. The algorithm is designed in such a way that no two hashes are the same for two different texts. And it is impossible, almost, to go back from the hash value to the original text. It's kind of like a cow moving on stairs. It can move upstairs but not down. Let's understand this with an example. In the below example, we have applied the SHA-1 algorithm. Let's see how it goes. Now if we make a tiny bit of change in the sentence above, the hash value will change entirely. Let's see how it goes. See how the hash value changed entirely when we remove those from donuts. That's what hashing does for you. What is encryption? It's almost impossible to imagine the internet without encryption. Encryption is what keeps the artificial world of the internet secured. Encryption keeps data secured and confidential. Fundamentally, it is the process of transforming your confidential data into an unreadable format so that no hacker or attacker can manipulate or steal it, thereby serving the purpose of confidentiality. The encryption of data is executed through cryptographic keys. The information is encrypted before it's sent and decrypted by the receiver. Therefore, the data is safe when it is in the air. Based on the nature of the keys, encryption can be classified into two main categories: symmetric encryption, asymmetric encryption. Let's understand them in detail. Symmetric encryption. In symmetric encryption, the data is encrypted and decrypted using a single cryptographic key. It means that the key used for encryption is used for decryption as well. Asymmetric encryption. Asymmetric encryption is a relatively new technique compared to its counterpart. It involves the use of two different keys, one for encryption and one for decryption purposes. One key is known as a public key and the other is regarded as a private key. When you send any data to an encrypted site, it is encrypted using the public key. The private key, on the other hand, is only with the receiver and must be kept discreet. Private key is used to decrypt the encrypted data. The use of two distinct keys makes the encryption process more secure and a tad slower. What is encoding? Unlike encryption and hashing, encoding is not used for security purpose. Fundamentally, it is just a technique to transform data into other formats so that it can be consumed by numerous systems. There is no use of keys in encoding. The algorithm that is used to encode the data is used to decode it as well. Examples: HTML encoding, URL encoding, Unicode encoding, base64 encoding, hex encoding, ASCII encoding, base64 encoding. What is obfuscation? Obfuscation is a technique that is normally used to hide the meaning of some software by rearranging the operations, but it can also be used to add weak watermarks to the code. In both cases, the algorithms rely on a collection of transformations that change the apparent operation of the software without changing the results. An obfuscated program should produce exactly the same results as an unobfuscated one. The purpose of obfuscation is to make something harder to understand, usually for the purposes of making it more difficult to attack or to copy. One common use is the obfuscation of source code so that it's harder to replicate a given product if it is reverse engineered. Conclusion: hashing is for validating the integrity of content by detecting all modification thereof via obvious changes to the hash output. It is a one-way process and almost irreversible. Encryption is for maintaining data confidentiality and requires the use of a key, kept secret, in order to return to plain text. Encoding is for maintaining data usability and can be reversed by employing the same algorithm that encoded the content, i.e. no key is used. Obfuscation is used to prevent people from understanding the meaning of something and is often used with computer code to help prevent successful reverse engineering and/or theft of a product's functionality. That's all for today, guys. Hope this video helps. We publish video every week. To stay up to date and aware of such cyber risks and learn about more hacking tools, consider subscribing to my channel by clicking on the subscribe and bell button on the top right corner of the page. Thanks for watching. See you soon in another episode.